Now here we will discuss about a very important topic, solid angle. If you draw a circle, center of the circle, and this is the length of the arc S and radius of the arc R, this theta is the plane angle. So theta is defined by S by R, length of the arc divided by radius of the arc, and the unit of theta is radians, RAD. So it's actually radians. Now same way, solid angle is a three-dimensional angle. If you have a sphere and say you cut a certain part of the sphere, and after you cut the certain part of the sphere, this sort of this thing is formed, this much area. So this much area, this three-dimensional angle subtended at the center, this is the three-dimensional angle subtended at the center, call it omega. This omega is known as the solid angle. So this solid angle is this area A. If the area of this sphere, this part, this area is A. So solid angle is A by square of the radius, R square. Now how to find out A? Now the corresponding plane angles are theta h. That means it is sort of a cone, you can say a cone. Now the semi-vertical angle of the cone, which is the plane angle theta, but the solid angle, that is a three-dimensional angle subtended at the vertex of the cone, it is omega. So now we will find out a relation between this theta and the solid angle omega. So let's go to next page. So now if you have a sphere, the center of the sphere, you cut a certain part of the sphere, we are going to find out the area. So for that I need to do what? Take a certain angle phi here. Take a certain angle phi here, and also this is d phi. Now take this small length, so it is r d phi. R is the radius, so r d phi, and this is this. So the area of this circular strip. So now we will find out the area of this circular strip. So area of this circular strip is how much? This is, so this length is r d phi, while this much is r sin phi. So this small area dA is r d phi multiplied by r sin phi. Rather, the radius is r sin phi, so the circumference will be 2 pi r sin phi, right? Because see, when you open up the thing, you get this is 2 pi into radius. Radius is itself r sin phi, and this small thing width is r d phi. So therefore dA, area is 2 pi r square sin phi d phi. Now you have to add up all these areas. So you need to add up all these areas. After you add, you get this area, this large area A. So now A is equal to integration of 2 pi r square sin phi d phi. Now integrate from, so let's keep phi a variable, from 0 to theta. So it is 2 pi r square. So integration of sin theta is minus cos phi. So from 0 to theta, so that means it is 2 pi r square into minus cos theta minus of 1 minus of minus 1, you get plus 1. So this area is 2 pi r square 1 minus cos theta. So the solid angle subtended there, this is the solid angle, right? The three-dimensional angle, solid angle omega. This omega, as you know, it is a by r square, so it is 2 pi into 1 minus cos theta. So this is the relation between the solid angle omega and the plane angle theta. That means if you have a cone sort of a thing, this semi-vertical angle of the cone is theta. So this solid angle omega is given by this omega is 2 pi into 1 minus cos theta. So this is the relation between plane angle and solid angle. For example, say there is a disc of radius r and say this is a distance x. So you can ask that, say this is point O. What is the solid angle that the disc subtends at this point O? So what is this solid angle? Omega equal to this 3-dimensional angle omega equal to. So now we have to first find out the plane angle, that means that semi-vertical angle of the cone, like that. So you know what is cos theta equal to? Cos theta, as you know, this part is root over of r square plus x square. So cos theta is x by root over of r square plus x square. Now we will use this formula. So omega solid angle is 2 pi 1 minus cos theta, x by root over of r square plus x square.